In this video, we are going to be taking a look at equivalent ratios. Now, the goal for today is to determine if two ratios are equivalent. And the essential question that we are going to be focusing in on is how can you determine if two ratios are equivalent? Now, we are going to take what we know about reducing fractions and equivalent fractions and using that information to help us determine if ratios are equivalent or not. Now, first of all, I want you to turn to page 263 in your standards practice book, and we are going to unlock this problem together. Now, keep in mind a couple different ways that we can write ratios to begin with. We can write it, for example, 2 to 3 with a colon, or with the number of the word 2, or we can write it as a fraction. And in today's lesson, we're going to write all of our ratios today as a fraction, which will really help us out in finding equivalent ratios. So the beginning here, let's take a look at this problem. Let's unlock the real world example. It says to make brass, you can mix 2 parts zinc to 3 parts copper, a ratio of 2 to 3, which I'm sure all of you already knew how to make brass. Okay, so if you have 12 parts of copper and use them all, how many parts of zinc do you need to make brass? Okay, so since ratios can be written as fractions, 2 to 3, like I just showed you, can be written as 2 to 3, just like that. And we're talking about using what we know about equivalent fractions to find equivalent ratios. Okay, now remember, equivalent fractions are fractions that are just equal. Okay, in other words, they represent the same amount, even though they may have different digits or different numerator and denominator. For example, 1/2 and let's say 8/16 are equivalent fractions. There's not one that's equal to or greater than another one. They're both equivalent. Okay, so we're going to use what we already know to help us learn something new. Okay, now our step 1 says draw bars to represent 2 to 3 ratio of zinc to copper. So we have 2 examples of zinc, 3 coppers here. Okay, so now we're going to keep adding to that ratio until we hit 12 bars of copper. Okay, so we have 2 parts zinc, 3 parts copper. Now we have 4 parts zinc, thinking of this whole entire group, 6 parts copper, 6 parts zinc, 9 parts copper, thinking of everything here, and finally 8 parts zinc, 12 parts copper. Okay, so there are 8 zinc bars, so 2 to 3 is equivalent to the ratio of 8 to 12, because I have 8 to 12 here, and the original ratio was 2 to 3. Okay, now how do we know that they're equivalent? If I think about what do I need to do to 2 in order to get to 8, I multiply that by 4. Okay, what do I need to do to 3 in order to get to 12? I multiply that by 4 as well. Okay, so 2 to 3 and 8 to 12 are equivalent ratios and also equivalent fractions. So let's take a look at a few more examples here. Let's take a look at the problem at the bottom of page 263, and let's do this together. It says use equivalent ratios to find out if 6/8 is equivalent to 18/24. Now, it is important to know that whenever we're taking a look at this, that we need to think about fractions and what we know about fractions. And whenever we're trying to find equivalent fractions or to see if fractions are equivalent, the easiest way to do that is to just simplify both fractions to the simplest form, and then you compare. Okay, so you can see for step 1, wrote the 6/8 ratio as a fraction, 18/24 as a fraction here. Step 2, you can see that 6/8, if you simplify that, does give you 3/4. 18/24 you divide by the greatest common factor, which is 6. Simplest form is 3/4. So both ratios equal 3/4, so they are equivalent. So you can see the steps. First of all, you turn it to a fraction, then you simplify both fractions, and if the simplest form are both equivalent, then you have an equivalent ratio. Now we are going to look at the share and show section together, and let's take a look at first of all the first section. It says, are the ratios 3/5 and 12/20 equivalent? Okay, so the first thing I want you to do, and you may even need a math journal for this because it's going to be hard to fit it all right on that sheet of paper. We're going to write both ratios as 3/5 as fractions and 12/20. Okay, so I want you to write both ratios as fractions. Okay, we'll even do it right up here, but you'll have to do some of this work in your math journal there. Okay, now are both ratios in simplest form? Now we know 3/5 is in simplest form, and the reason why, there's not any digit that can both go into 3 and 5 equally other than 1. Okay, now 12/20, we know that is not in simplest form. So are both ratios in simplest form where there's one but there's not another, not both of them? Okay, so the answer to that is no. Now what we need to do, we need to write both ratios in simplest form. So 3/5 we can easily just rewrite in simplest form. Okay, now 12/20, what we need to do is we need to figure out the greatest common factor, okay, that can go into both 12 and 20, or 12 and 20 are the greatest common denominator, whatever you would like to call it there, that can go into 12 and 20, okay, and we know that the greatest common denominator is going to be 4, okay, so we can divide that 12 by 4 and that denominator by 4. So we have 12 divided by 4, that's going to give me 3. 20 divided by 4 will give me 5. Okay, so that's 3/5. So we have 3/5 and 3/5. What do you know? Okay, are the ratios equivalent? Well, we know that they're equivalent because we simplified both fractions, and when we simplified them, they both are equivalent. So their ratios equivalent? Absolutely. Okay, yes, they are equivalent. Okay, let's take a look at number 2 now. We'll do this together. Okay, 1/3 to 2/6. Are they equivalent? Yes or no? Let's first of all think through the process. Write them down as both fractions. So we have 1/3 and 2/6. Okay, now are they equivalent? Yes or no? We don't really know if they're not in simplest terms, so we need to figure out if they're both in simplest terms. So we know 1/3 is in simplest terms. Now 2/6, the greatest common denominator of 2/6 here is just going to be 2. Okay, 2 divided by 2 will give me 1. 6 divided by 2 will give me 3. And we can see here we have 1/3 and 1/3. So our 1 to 3 and 2 to 6, are they equivalent ratios? The answer to that is yes. Okay, let's take a look at number 3 in the share and show. We have 3/7 compared to 12/21. Okay, first of all, 3/7, we know that is in simplest terms. The reason why we know that is because there's not any other number other than 1 that can go into both 3 and 7 evenly. Okay, especially when you're dealing with two prime numbers, you for sure know that it's going to be in simplest terms. Okay, now 12 and 21, that's a different story. What we need to do is we need to simplify this to simplest terms. Okay, now the greatest number that can go into both 12 and 21 is going to be 3. Okay, so what we do to the numerator, we must do to the denominator. 12 divided by 3 is going to give me 4. 21 divided by 3 will give me 7. Now, pretty simple to see, 3/7 and 4/7, they are not equivalent. Okay, so number 3, 3/7 and 12 to 21, write equivalent or not equivalent. Okay, number 2, I should have just written equivalent there. For this, number 3, it is not equivalent. Why do we know that's not equivalent? Because we simplified both fractions, and both fractions are not equivalent. Okay, so the ratios are not equivalent. So we'll just write not equivalent here. Okay, now this is a little bit different twist to this. It says write the equivalent ratio. So what they have given to us for number 4 is they gave us the ratio. We need to figure out the missing ratio in order to make it equivalent. So think about finding a missing denominator or numerator. Whenever you're trying to find equivalent fractions, take what you already know and apply it to learning something new. Okay, so we have 5 over 2 equals what over 4? So we need to think about, what do we do to 2 in order to get to 4? What we do to 2 in order to get to 4, we multiply it by 2. Okay, now remember, with fractions, you either have to multiply or divide. You can't just add 1 or add 2 or anything like that. Okay, so we're multiplying the denominator by 2 in order to get to 4. So whatever we do to the denominator, we must do to the numerator. So we multiply that numerator by 2, which gives us 10 fourths. Okay, so 5 to 2 is equivalent to 10 to 4. Now number 5 is a little bit different because it's not like number 4 in that we can just easily see that we multiplied 2 by 2 in order to get to 4. So whenever we have something like this, 3 to 6 and 7 to what? Now there's nothing that you can multiply by 3 in order to get to 7. So what you have to do here, you do have to simplify this ratio to in its simplest form. So what we will do, we know 3 to 6, okay, we can divide both by 3, and that gives us 1/2. Okay, now what we want to do, now this is in simplest terms, we want to take that 1/2, alright, now, and try to make an equivalent fraction now from that simplest terms to that 7 over something. So we think, okay, what times 7, what times what will give us 7? I gave it away there. 1 times 7 will equal 7. So therefore 2 times 7 is going to be that missing denominator there, that missing part of the ratio. So we have 7 to 14. So 3 to 6 is equal to 7 to 14, and we know that because if we were to simplify both ratios as fractions, then they would both be simplified down to 1/2. So what I want you to do is number 6 through 12 all by yourself. You definitely will need a math journal as you do these problems, and when you're finished with them, you can press play and I'll have the answers for you. So pause the video now. Okay, here are the answers for numbers 4 to 12. I want you to check your answers and make sure they do match mine. If they do not, you may need to rewind this video and watch a couple more examples over again. Okay, let's take a look at number 13 now. It says 3 of every 5 pizzas at Midgie's Pizza sells are cheese pizzas. Miggy's sold 80 pizzas today. How many of them would you expect were cheese? Now it's important to understand that this is a part to a whole ratio, 3 to 5. Okay, so what we have here, 3 to 5 is equal or equivalent to what over 80. Okay, now this we can do pretty easily here. Okay, and that 3 to 5 is in simplest terms. Okay, now whenever a ratio is not in simplest terms, you may run into a problem like we did for number 5 up here. But when it is in simplest terms, what you need to do, you need to think about, get my pen to work here, there we go, 5 times what gives you 80, okay, and we could even do 80 divided by 5. Now that's going to give us 16. Okay, so we multiplied 5 times 16 to get to 80. So in order to get that missing ratio, or how many cheese pizzas there, we take 13 by 16. Okay, and that's going to give us 48. Okay, and 48 cheese pizzas. Okay, now answering this essential question. And the answer to this is, if two ratios are written as fractions in simplest form are equal, then the two ratios are equivalent. Okay, so this is how you find equivalent ratios. If you have any questions about this concept, please come and see me.